Architecturally exposed structural steel, design with detail. Part 2, coatings and protection. This presentation is brought to you by the Association of Collegiate Schools of Architecture. My name is Terry Meyer-Boak. I teach architecture at the University of Waterloo, and my passion is steel. The core idea is about form, fit, and finish. These two trees are both AESS, yet each is quite different from the other. So why would the AESS specification be even remotely the same? One is using angular materials with a combination of welding and bolting, the other using tubular material and special cast nodes for the connections. The airport has a less glossy finish on the steel, and the university uses a high gloss paint. When designing with AESS, you have to think carefully about your goals in the design of the project. As is shown by the two trees, even selecting the idea of a form does not necessarily infer or limit member choices, connection types, or finishes. And really, the finish must come first as it impacts the detailing choices. The higher the gloss of finish, the more demands are made of the fabrication detailing. The high gloss steel in the Guelph Science Building tree came together like this. The finish required very careful fabrication detailing to make the welded connections smooth. The primer is held back from where the welding will take place. Steel generally arrives to the site with a primed finish. This protects the steel from excessive corrosion during the construction period. Primers vary, and their chemistry must match the final finish. This brings us to our next major factor, the coating and protection system. This will include fire and corrosion protection. Ultimately, the nature and final finish of the system needs to be known at the outset of the project, as it impacts what aspects of the detailing show through and what will be somewhat masked. Whether you're going for a high gloss, medium gloss, normal intumescent, thicker intumescent, or galvanized coating will impact the warranted detailing. Fire protection requirements need to inform the overall design strategy. Often buildings will use a combination of a fire suppression system and an intumescent coating. Intumescent coatings expand to create a protective thickness over the steel when it experiences the high heat of a fire. The thicker the intumescent coating, the longer the protection. Although intumescent coatings are able to be pigmented to resemble a painted coating, it is important to understand issues of color matching if the steel is located in high traffic areas that may require periodic repair. An intumescent coating will have a finish akin to the texture of an orange peel. This varies between thin and thick applications, but it is important to think about the texture as you are detailing the steel. A project like this requires that much of the finishing of the steel be done on site. The elements arrived primed to protect from weathering during the install. The primer was held back from the weld connections to allow the welding to take place. After the welding was complete, the priming was extensively touched up in preparation for the multi-coat intumescent to be applied. Although galvanizing has become quite popular, you need to realize that it is primarily a corrosion protection system and will vary depending on the size of the member and its thickness. So expect it to look quite technical and rugged, with many inconsistencies from piece to piece. Steel structures that are specified as galvanized will have their elements dipped in a molten bath of zinc. The elements must be designed with thick enough steel to withstand temperatures of about 450 degrees Celsius or 840 degrees Fahrenheit without deformation, and must also fit in the bath. The thickness of the zinc-based galvanic protection will depend on the adhesion to the structural steel. The thicker the steel, the thicker the protection layer. This project uses galvanization as the protection system for the exposed steel decking, wide flange truss, and round HSS columns. The design is detailed to allow the elements to be small enough to be dipped in the hot zinc bath. Galvanized steel can be welded or bolted. The welding will be carried out prior to dipping. Here, these tightly designed site connections were carried out via bolting. The selection of a galvanized finish for this semi-enclosed public space was quite deliberate to enhance the chaotic ruggedness of the design. Galvanized decking was also used. You can also notice the very light cross bracing in the plane of the roof used to stabilize the eccentric geometries of the structure. The steel support system for the Art Gallery of Ontario used a combination of galvanized steel and zinc-painted steel. The long ribs were too large to fit in the galvanizing bath, and there was concern that the heat would distort them. The shorter components and the connections to the glulam timber were hot-dip galvanized, as they would fit in the bath, and distortion was not a concern. The color match between the two finishes is reasonably close, and the ultimate position of the steel, which is quite distant, though exposed, is somewhat hidden by the glazed facade components. This award-winning bridge uses a zinc-based system to achieve its corrosion protection. When designing steel in areas exposed to high levels of moisture, detailing is critical, even down to the selection of fasteners. The thinner the steel, the thinner the layer of galvanizing, and the more susceptible the members are to eventual corrosion. The custom curved box section structure of the Bird's Nest Stadium needed a heavy-duty corrosion protection system, but due to the sheer size of the members, hot-dip galvanizing was out of the question. The surface of the members was first roughened, followed by 2 coats of a spray-applied intermediate layer of epoxy micaceous iron oxide, followed by a spray-applied metallic gray fluorocarbon finish. Weathering steel has become a popular material that is corrosion resistant. It needs wet and dry cycles to develop the oxide layer that will arrest further corrosion. This pedestrian bridge that forms the entrance to the 2012 Olympic site in London, England, has used weathering steel. You need to understand that this material is only manufactured in plate form, not as standard hot-rolled sections, so all designs using weathering steel will need to be designed from fully custom sections. Special weld material is used to weld weathering steel plate elements together. Stainless steel is also a very durable option if you are looking for corrosion resistance. Stainless steel is commonly manufactured in tubular and plate material. It requires special engineering and careful fabrication with dedicated equipment. The National Archives building was designed to last hundreds of years, and so stainless steel was chosen for its exposed structural system in order to guarantee durability. Stainless steel has been used for the custom fabricated plate elements, threaded rods, and bolts. When thinking about design for durability, the selection of color is a very important consideration. Although many architects like to select white, it tends to discolor and stain due to the effects of pollution. For uses such as transit stations, car parks, and train stations, it is best to consider alternate colors. The importance of detailing to shed rather than collect water, ice, and snow cannot be stressed enough. This exterior walkway has also been subjected to the use of salt as a de-icing agent with disastrous results. Detailing needs to ensure drainage, as is the case for the Seattle Public Library. Small cutouts where the web members meet serve to allow drainage and relieve stresses when the connections are welded. The bottom line for exposed steel is that the finishes, be they for simple finishing, weather, or fire protection, must be selected at the outset of the project so that the detailing can be done in an appropriate manner in concert with the gloss or thickness of the finishing material. I've only touched upon some of the basic ideas behind issues of finishes in exposed steel design. For more information and lots of case study examples and photos to inspire your work, feel free to connect with me on my AESS Facebook page. And for more detailed information on designing with architecturally exposed structural steel, check out this book on the topic. It is filled with plenty of photos like the ones included in this presentation and more valuable tips on coatings and protection, as well as fabrication, erection, design, and detailing.